And welcome back. So just before the break, I said we are going to look at creating half reactions from a simple redox reaction. So a redox reaction is a chemical reaction where electrons are transferred between entities. So I've kind of been using this term redox here. And so this is our thermochemistry unit, and we're looking at a lot at this term of redox. So I'll pull up my highlighter, and a redox reaction is a chemical reaction where electrons are transferred between entities. So entities just mean that electrons are being transferred between species in the reaction. In a redox reaction, the total number of electrons gained in a reaction must equal the total numbers of electrons lost. So electrons gained, and just make sure you're paying attention. I will use a creative pen here, and I will use the rainbows thing, and I will go equals, and electrons gained is equal to what? Electrons lost. Oxidation and reduction occur simultaneously rather than sequentially. What that means is that simultaneously, so oxidation and reduction, redox is occurring at the same time. All right. So we have a practice question here for us to go over. And it says, write a pair of balanced half reaction equations, one showing a gain of electron and one showing a loss of electrons for each of the following reactions. All right. We'll write our red and we'll write our ox. This is just kind of a shorthand of writing reduction and oxidation. So my reduction. Which species is undergoing reduction? Remember, we have our acronym. Like I said, I will refer to it. Oxidation is loss. Reduction is gain. Let's take a look at zinc. Zinc is starting as a solid, and it is becoming an ion. So it's an atom to an ion. Now, is zinc losing or gaining electrons? So again, oil rig. Oxidation is loss. Reduction is gain. So this just went from a charge of 0 to a charge of +2. Copper went from a charge of +2 to a charge of 0. Which means that, so I said we were looking at zinc, we're going to switch gears. Let's look at copper, because it's going from +2 to 0. If you go from +2 to 0, and you're gaining, you can only lose or gain electrons, then you have to be gaining, because you're going from a positive to a negative. So we have Cu2+, which is aqueous. And I'm just going to put a blank electrons here for now. Electrons produces Cu solid. How many electrons do I need to convert copper 2+ to copper solid? I need 2. That is my reduction half reaction here. So I'll actually, just so I know what it is, I'll put a square around it. And then let's take a look at my oxidation half reaction. So we know at this point, we already said that copper is undergoing reduction. It is gaining electrons. Zinc starts out as a solid, and it is losing electrons. So it's going to become zinc 2+. It becomes an ion, 2+, and it gains 2 electrons. When we go to write our net, we would just cross off our electrons. It only wants our 2 half reactions, so I'll just put a box around here. And that is all it is asking for us as of here. That's our first question. We have another example here. If I'm just going to give you a moment here to take a look over that. Again, there are the completed notes on Google Classroom, so you'll be able to look at those as well. All right, our next question here is saying write and label two balanced half reaction equations to describe the reaction of zinc metal with aqueous lead 2 nitrate as given by the following chemical reaction. All right. Going back to our notes on the first page here, one of the things we notice is that ions are converted to atoms and atoms are converted to ions. Scrolling down, we've already seen nitrate in this example here, and nitrate is always going to remain as an aqueous solution or species. Again, we could take a look at this here. I will pull out my pen and I'll do a broken pink. So zinc is solid here. Lead is solid here. Nitrate is aqueous. Nitrate is aqueous. Already, we know one thing. Nitrate is out. However, though, I still do need to know what my lead ion and zinc ion charges are going to be. So I'm going to take those off here. And my zinc is solid, but my lead, we know nitrate is a +1. So for every one nitrate, we have to have, nitrate is -1, and we have 2 leads. So if this is -1, and we have 2 of them there, then this means that this has to be +2. So I have lead 2+, and over here I have zinc 2+. I'm going to set this up again as the last one. Reduction, oxidation. And I want you to take a moment to decipher or think about which is going to be undergo reduction and which is going to undergo oxidation. All right, I've given you a moment there to think about that. I'm going to write down my acronym again. Oil rig, oxidation is loss, reduction is gain. Reduction is gain. So lead went from +2, 2+, to 0. Which means that lead is undergoing reduction. It's gaining that electron. It's going from +2 to 0. So this will be Pb 2+ over to lead solid. All right, similar to our last one, zinc is a solid and it undergoes oxidation plus, how many, plus zinc 2+, make sure to put our state, which is aqueous. All right, that leads us into practice sheet 1. I will have solutions posted later. I want you to do this on your own. This is a little bit of a challenging concept. It's a little bit confusing. Once you work through some examples, though, you'll begin to be able to see, oh, hold on. Solutions are there on the completed package. However, I still encourage you to do it on your own and then check your answers. All right, once you have completed practice sheet 1, please hop on to the next section, which is writing half reactions for complex redox reactions. So I'm going to stop this screencast here, and then we'll have a separate one for the last bit of lesson 1 here.